Friday we talked about the exponential graphs and basically the exponential function. Today is the logarithmic function and their graphs.
Oh my god,
Remember at the beginning here, it's talking about the exponential function would pass the horizontal line test. So it's 1 to 1, which means we can go ahead and find its inverse, and we call that a logarithm. So your basic job, is to be able to go back and forth. So let's call it log base b of some number is equal to y, let's say. When you write out your logarithms, I want you to make sure that you put the base down in subscript notation. It needs to be moved down on the G, if you will, further down. The logarithm of a number, they go next to each other, and then it's equal to some other number. And you'll hear me say it probably over 100 times probably in the next week or so. Logarithms are always equal to the exponent. So when you go to rewrite this, logarithms are always equal to the exponent. So the bases will always be the same. So whatever your base is when you work with logarithms will be the base when you work with the exponential. Logarithms are always equal to the exponent, so y would be my exponent in this case. And then the only thing left is to set it equal to x. So back when we worked on inverse functions, we switched out the x's for y's, and then we solved again for y to get the inverse function. Well, here all you have to do is rewrite it. There's nothing to do except rewrite it. So the expectation is you can flip-flop back and forth between those very quickly. Now, when you evaluate, when you see the word evaluate, they're talking about give us the number. In a day or two, a lot of these, you guys will just know the answer to them, and that's fine. Write it down. Log base 2 of 8 is equal to what? If you don't know it, come up with some variable. I tend to use w's for whatever reason. So my base is 2. My exponential base is 2. Logarithms are always equal to the exponent, so that means w is the exponent, and it's equal to 8. So 2 to what power gives you 8? How many 2's have to be multiplied together? 3 of them. So your answer is 3. 2 times 2 times 2 is 8. Part B. Log base 2 is 0.25. Again, maybe you'll call it w. 2 to the w equals, I think it's easier if you switch that decimal out to the fraction. So instead of 0.25, let's call it 1/4. Because what did we talk about with exponential functions? What causes a base to flip into that reciprocal form? When you take a base and flip it. When it's negative. So now I know w, the exponent must be negative, right? 2 to what power gives me that 4 down here? Quickly, do C. Show somebody sitting near you what you get for an answer. If you're super smart, do part D. How many 3's do I have to line up to get to 81? What's that? 4. So the answer is 4. 3 times 3 times 3 times 3. How about log base 10 of 100? Two. Little note there. Base 10, our number system that we work with is a base 10 number system. So base 10 logarithms are used a lot in mathematics. So we generally do not write log base 10. we will write it, if we call it the common logarithm, and instead of writing the log base 10 like we did here, you might just see log, so no 10 there. So on your calculator, if you look next to the number 4, right? Next to the number 4 is an log button, log button. If you look right above it, the notation is 10 to the x. So you can tell right there on your calculator that log means base 10. Okay, so 10 to a power gives me negative. Ten to what power gives me negative 1? Somebody draw in the air for me what the exponential function looks like on the graph. What does the exponential function look like? Yeah? Yeah? Right? It's going to go along the x-axis. What does it hit for an intercept? 0, 1. And then it kind of rises up. So it's doing this. So that's 10 to the x. We talked a lot about it has this horizontal asymptote at y equals 0, right? So does it touch 0? No. So does it ever go into the negatives? No. So your basic exponential functions never go below. Now, if I do some shifting and stuff, I can get this thing to drop down 5 or 6 or 7 or 8. But in this case, there are no solutions. So if you hit that button on your calculator next to the 4, it's the log button. Type in the negative 1, your calculator errors out, and that's why. Those graphs never go into the negatives. So 7 to a power gives me negative 14. Doesn't matter what base it is. Does not matter what base it is. So, questions on any of it? There are some basic properties when you're working with logarithms. So when you look at the logarithm on the left, they're just using base A. So it doesn't matter what the number is for your base, log base, whatever. If you're taking the logarithm of 1, the answer is 0. Because when you look in exponential form, you would rewrite it, your base is a to the 0 power, because logarithms are always equal to the exponent, so 0 is your exponent. Any base to the 0 power is 1. So you have your logarithm rule on the left, exponential rule on the right. If you're taking the logarithm where you're taking the log of some number and that some number is the base, it has to be equal to 1. 3 is what I refer to as the Chunga property. They undo each other. That literally right there is the inverse property. If you are using a logarithm base 5, and then you're taking that logarithm of the exponential, also base 5, so in other words right here, your bases are the same, they undo each other. So the only thing left is that number x, whatever it is. The last one, number 4, is kind of what I call a one-to-one property. We're setting two sides of the equation equal to each other, and some things are the same, and we set stuff equal to each other. So right away, this is log base 5, and that's log base 5, right? So I have logarithm on one side, logarithm on the other. They're the same base. Well, the equal sign tells me that the left is the same as the right. So what do you know about the x and the 8? They have to be the same. So there are going to be times when we work with logarithms that we'll do a bunch of work to one side to squish it down into one logarithm so that we can use that property. How about B?
0.
That's an evaluate situation. Those are things that eventually, hopefully in a day or two, you've done it, you'll practice enough of these, that you'll be able to tell me the answer just by looking at it.